Now being recorded.
Other than Prajakta Yadav, Kulkarni, anyone? Only Prajakta Kulkarni is a respondent. What about others? What is cellular concept? What is an cell? What is the shape of cell? What is an cluster? Tell me the answer first. I'm asking you people. What about others? Dipali, Anandpure.
Yes, sir.
What is cellular concept?
Large graphical area is divided into small cells is known as cellular concept.
The large geographical area is divided into a smaller cell, that is called a cell. What is the shape of cell? What is the shape of cell?
Hexagonal. Hexagonal.
Okay, hexagonal cell has finalized. The whole world has finalized the hexagonal cell. Why? Because it is going to cover more and more area, so it is finalized. Okay, what is a cluster?
It is group of cell having non-overlapping frequency.
A group of cells having a disjoint frequency or a non-overlap frequency, that is called as a cluster. Okay, next, frequency reuse. Other than these two, I have to take the names or what? Megha Bhosle, Vaishnavi, Aarti, Shweta Jamdade, Prajakta More, Pratiksha Patil. What is a cluster? What is frequency reuse? Tell me first. Which are the types of channel assignment strategies? Kaustubh.
Yes, sir.
Types of channel assignment strategy. Don't know Kaustubh? Mayur. Rushikesh. Sunil. Shubham. Prathamesh. Those who are not responding, I will put absent for them. Keep in mind.
Yes, sir. Roll number 70.
Shubham. Tell me the answer. Which are the channel assignment strategies? Roll number 70 attendance लेके भाग गए क्या? Shubham, I'm not taking the attendance. I'm asking you the question.
सर येत नाही त्याचा आन्सर मला जे मी कालच्या लेक्चरला होतो त्याच्या अगोदरच्या लेक्चरला नव्हतो मी.
काय झालं? अगोदर नाही, काल झालं ते लेक्चर. काल होत आहे ना
हा होतो सर.
मग काल होत आहे ना तू
हा होतो सर.
मग मग सोलर कॉन्सेप्ट म्हणजे काय आत्ता प्रोजेक्ट कुलकर्णी बोलले नाही डेफिनेशन ऐकायला आले नाही अभिषेक माने based on your response I'm going to finalize your term work. Keep in mind if you're not responding properly I will put only 12 marks for a passing marks. The term work has 10 marks and IS is 12. Keep in mind those are responded immediately they will get good marks. I told you previously from a first lecture itself I will take a seminar on the basics of whatever I have covered the syllabus. I am going to take a seminar on one day, but little bit the content has to be covered. After once the content has been covered for first unit, I will start taking the seminars. Be prepared. I am starting telling you from a first lecture itself. Those who are given seminars, I will note it down here. Those who are not given, you will be responsible for that, for a term work, because there is a tutorial is there. For a tutorial you have to give the seminars and you have to submit the tutorial questions and answers. You have to write that question answers and submit it. Keep in mind. Okay, I know you will not respond just for the sake of attendance. You are attending this is not good. Okay, yesterday we have started a handoff strategy. A handoff is nothing but what? Whenever we are crossing the many number of base stations, that is base transceiver stations and base station controllers, we are getting the many number of channels, the different channels we are going to get for a different multiple callings. That is handoff is going on. That has to be taken care by one of the, that is head, that is mobile switching center. All the observation, all the monitoring has to be done by this mobile switching center. And this is what the one of the diagram you have seen yesterday, that is base station 1, base station 2. Instead of base station we can call it as BTS, that is base transceiver station 1 and base transceiver station 2. And there are two cells we have mentioned in this, that is cell 1 and cell 2. At the edge of this cell 1 there is a at the previous, that is initial, that is B, that is A is going to hand over for a B BTS, that is to be in a very short time. It has to be handoff has to be starts and handoff is going to ends. Okay, for handoff process we have to calculate the power margin. For that power margin is nothing but what, how much you are getting the powers. Okay, you have to minimize the power and power margin has to be defined by, that is del. The del is equals to PR of H minus of PR of min. You have to remember this. A del that is assigned by the power margin, that is assigned by the del, that is del is equals to PR of H minus of PR of min. The PR of H is nothing but what, that has to be minimum acceptable level. PR of min, that is minimum maximum minimum acceptable level, and PR of H is a stronger level. If we are using the Nokia set, that is previously we are using that is we are using the slightly the minimum acceptable, that is you are not getting the maximum amount of channels for that. Nowadays we are using the smartphones. For smartphones the network is very high, so that is what we are going to get. We are going to calculate the power margin for that. How much is the power? Nowadays we are using, once we have charged your mobile, we can use for a full day for that mobile charging. So that is what we are going to minimize. That is, you have to maintain a constant power margin for that. That has to be assigned by del is equals to PR of H minus of PR of min. If this power margin is too small, it has to be complete. It is another time to complete the handoff. So for that that has to be taken care by the MSC, that is mobile switching center, that it has to be medium, that is del, that is more power margin has to be medium. If it is too small, it has to be taken maximum time to time to complete the handoff. If it is too high, MSC has to burden for a unnecessary handoffs. This is what we are using to use the power margin, that is del. If it is too small, it has to be time to complete the handoff. If it is too high, MSC has to be burdened for the handoff. So power margin has to be calculated properly on this. Where it is using this handoff priority, this handoff priority has to be taken care when your call will be disconnected. Your call will be disconnected in between. Already the channel has been assigned to you, but in between the networks, due to network problem, your call has been disconnected. That handoff priority has to be taken care by. The dropped call has to be considered first. The channel has to be allocated immediately to that disconnected call. That has to be taken care by this handoff. And if the call has been connected, the MSC has to be taken care that the maximum number of channels has to be available at that particular cell. It has to be taken care that the maximum number of channels has to be available at that particular cells. That has to be taken care by the dynamic allocation, that is dynamic channel strategies. We are using two. One is fixed channel assignment, second is dynamic channel assignment. This handoff priority has to be mainly taken care by this dynamic channel assignment strategies. So it is going to reduce the failure in the handoffs. If more and more channels, we can use create a priority that there is no handoff, there is no disconnect within the call. So that has to be, they have to be reduce the handoff failure. So that has to be considered for the user point of view. That has to be considered handoff priority. We have already told, that is, I already told there are two types of handoffs. One is soft handoff and one is hard handoff. Okay, there are two words we can call. One is handover, one is handoff. Two words are there. If you use some of the books, they has mentioned the handover. In some of the books, he has used a handoff. Handover has to be used in India or Pakistan, and handoff can be used in the US, United States. The word has been changed for a handover or handoff. You can, most of them has called both handoff or handover, but actually the words or the names came from that. Handover is from India and Pakistan, and from handoff is for United States. Two types of handoffs. One is hard handoff, one is soft handoff. This is very, very important for types of handoffs. If you want, you can write it. Types of handoffs. One is hard handoff or soft handoff, or hard handover or soft handover. Hard handover is nothing but what? It has to be one sentence is there, that is break before make. Write down this sentence. Hard handover. Break before make. For soft handover, make before break. Reverse of this. Make before break. What is the meaning of this? Hard handover is nothing but what? Break before make. Okay. Whenever, what is the meaning of this sentence? Listen. Break before make. First to break the first connection, connected call. First to break the first connection. After you can connect the next BTS. Break before you connect. Before you connect the other BTS, that is for a base station, you have to break the previous connection. First you have to break the previous connection, next you can connect the next connection. That is what break before make. That has to be used in a second generation and for fourth generation. Break before make, that is for handover. Hard handover we are using for 2G, that is second generation and fourth generation. Okay. Soft handover, that is make before break. Make before break. You have to connect the next connection first after you break the previous connection. First you have to connect the next connection, next you have to break the previous connection. That has to be taken for this soft handover. That has to be used in third generation. And mainly we are using for the soft handovers nowadays, that is make before break, so your call will not be disconnected in between. That has to be used in break before make. That is hard handover. Soft handover is make before break. Here some of the different handovers are there. That is it: intra BSc handover, inter BSc handover, inter MSc handover. BSc stands for base station controller. There are many short forms will comes. You have to remember the short form. That is a full form of that short forms. That is BSc stands for base station controller. BTS stands for base transceiver station. BS nothing but base station. MS is nothing but mobile station. MSc is nothing but mobile switching center. There are different types of handover in this. One is intra BSc handover, inter BSc handover, inter MSc handover. What it means, in India total 23 to 24 MSCs are there. In India total 23 to 24 MSCs, that is mobile switching centers, are connected from each other. That is MSc 1. See here, what happens in intra BSc handover? Whenever you are moving on the highways, you are crossing number of BTS, that is base transceiver stations. Okay, there is a vehicle is here, that is BTS 1. It is going to cross going for a BTS 2. Okay, if it is once you cross from BTS 1 to BTS 2, it is we are using the BSc 1, that is base station controller. Both the BTS are using the only one BSc, that is BSc 1, and that BSc 1 is connected to the common MSc, that is MSc 1. Okay, this type of handover is called as intra BSc handover. Changing only BTS, remains BSc and MSc same. Changing only BTS, remains BSc and MSc same. This type of handover is called as intra BSc handover. And BTS 2 moves to the BTS 3. Next, BTS 2 moves to the BTS 3. That is, vehicle is moved from BTS 2 to BTS 3. But the BSc has changed. See the diagram. BSc has been changed, and MSc remains same. MSc remains the same. That type of handover is called as what? Inter BSc handover. Inter BSc handover. BTS changes, BSc changed, but MSc remains same. BTS changes, BSc also changes, and MSc remains same. This type of handover is called as inter BSc handover. Next, again the same concept. BTS changes, BSc remains same, MSc remains same. This type of handover is called intra BSc handover. And the last, you move to the last station, that is BTS 4 to BTS 5. Last, the BTS changes, BSc also changed, MSc also changed. BTS changed, BSc changed, MSc also changed. This means what? Inter MSc handover. You have crossed the boundary. You have crossed a boundary. You have crossed the states. That is from Delhi to Punjab, Punjab to Haryana, Haryana to Kashmir, everywhere. If you have changed the states, number of states, that is means you have crossed the BTS, you have crossed the BSc, you have crossed the MSc also. This type of handover is called as inter MSc handover. Inter MSc handover. You have to remember this. Very, very important, very, very interesting point of this is what? Whenever you are crossing, whenever you have changed BTS, but BSc and MSc remains same, this type of handover is called as intra BSc handover. If BTS changes, BSc changed, but MSc remains same, this type of handover is called as inter BSc handover. And last, the BTS changes, BSc also changes, and MSc also changes, means you have changed everything. You have changed everything, that is BTS changes, BSc changes, and MSc changes, means you have crossed the boundary of Maharashtra and you have reached to the Karnataka state. That is what the MSc is also changed, BSc is also changed, and BSc and BTS is also changed. That is what this type of handover is called as inter MSc handover. Two types of handovers. One is hard handover, one is soft handover. This is what full explanation for this handover and handoff. There are different generations. There are different generations comes under this handoff. First generation, second generation, and third generation. First generation, second generation, and third generation. The first generation handoff is called as what? Network controlled handoff. First generation handoff is called as what? Network controlled handoff. Everything will be controlled by the network itself. Previously we are using this 1G. You are using the Nokia mobile, that is called as a 1G. There is only voice signals we have to use. We can speak only, we can send only messages, SMSs. That has to be controlled by the all. Everything will be controlled by the network controlled. That has to be monitored by the base stations. That has to be monitored by the base station. And the handoff, it is required a minimum of 5 to 10 seconds. The maximum time has to be required for the handoff, that is of 5 to 10 seconds, and the power margin required is of 6 dB to 12 dB. Power margin is required is of 6 dB to 12 dB. See the difference for first generation, that is first generation, it is to be controlled by the network controlled handoff. Network controlled handoff, you are using the voice channels, and MSC has to be monitored that and MSC, once the handoff has to be taken place, it takes a maximum time for the handoff, that is for 5 to 10 seconds for first generation, and the power margin required is of 6 dB to 12 dB. Okay, you have measured the power is in watt, that is watts per dB, decibels. So the power margin, that is del, in the order of 6 dB to 12 dB. And once we move from 1G to 2G, 1G to 2G, the digital technology has been started. The digital technology has been started. That is, the analog signal has to be converted to the digital, that is from zeros and ones. Okay, at that time, that handoff is called as mobile assisted handoff. That has to be used, that has to be controlled by the mobile itself. That has to be controlled by the mobile itself. That type of handoff is called as mobile assisted handoff. That type of handoff is called as mobile assisted handoff. So everything has to be controlled by this base station, that is BTS, and two BTS has to be communication with each other for the handoff. If the channel is not available, it has to be carried from the fixed channel assignment strategy, that is to be borrow the channel from the other cell, that is to be taken by mobile assisted handoff. And the last is third generation. Third generation we are using is the mobile controlled handoff. The third generation has to be used for mobile controlled handoff. For this 2G, it has to be taken for 0 to, that is to minimum time has to be taken for this handoff processes, that is for 0.5 GB. I think reduces 1 seconds. That has to be reduces the handoff is of 1 second, but it is taken for 1G is 5 to 10 seconds. But for 2G, it has to be taken for the handoff is of 1 second, and the power margin for this 2G is of 0 to 5 dB. The power margin for this 2G second generation is 0 to 5 decibels. And for third generation, this type of handoff is called as mobile controlled handoff. If you want, you can write it down. Mobile controlled handoff for third generation. So the handoff has to be taken place in a fraction of seconds. The handoff has to be taken place for fraction of second, that is for 100 milliseconds. Milliseconds is nothing but 10 raised to minus 3, that is for 0.001 second. In the fraction of seconds, the handoff has to be taken place, but we don't know how it has to be happened. For third G, that type of third generation is called as a mobile controlled handoff. Mobile controlled handoff, and the handoff has to be taken place in 100 milliseconds or 0.01. That is for a handoff has to be taken place, and the power margin we required is 20 decibels milli. That is milli. The power has almost reduced. You are going to save the power margin, that is 20 dB per milli, and we are going to increase the quality of service for this. We are going to increase the quality of service. So this is what a different types of generations, comes and handoff. This is not there in your syllabus, but for knowledge point of view, you have to remember this. Handoffs in different generations. Maybe you'll ask for a question for 6 marks. There is offline. If there is offline, you will ask for a 6 marks or the 4 marks. Explain the different generations of handoff. For first generation, it is called as a network controlled handoff, and for the second generation, it is called as a mobile assisted handoff, and third generation is called as a mobile controlled handoff. Write down this. The first generation is network controlled handoff, second generation is mobile assisted handoff, and the third generation is mobile controlled handoff. And the handoff has to be taken place for first generation is 5 to 10 seconds, 5 to 10 seconds, and the power margin for this is 6 dB to 12 dB. Power margin for this is 6 dB to 12 dB. For second generation, that is called as a mobile assisted handoff, and it has to be handoff has to be taken place for 1 to 5 seconds, 1 to 5 seconds, and for the power margin for this is 0 to 5 dB. Power margin for this is 0 to 5 decibels. And for the third generation, it is called as a mobile controlled handoff. For third generation, it is called as a mobile controlled handoff. The handoff has to be taken place for a fraction of seconds, that is 100 milliseconds, and the power margin for this is 20 dB per milli. 20 dB per milli. So this is what the overall concept of handoff. This is very, very important. This is very, very important. MCQ questions will be asked. What is the definition of handoff? What is handoff? There is a definition he has given in the options. You have to write down that options. That is handoff. Okay. And what is power margin? The formula. Power margin del is equals to PR of H minus of PR min. That is comes in MCQ. Okay. Next, soft handoff and hard handoff. Differences. Differences he is asked, and if you want to ask, that is for a sentence break before make or make before break. Different generations of handoff. That is 1G. That is called as 1G. That is first generation is called as network controlled handoff. What is the handoff? Second, that is a time, and what is the power margin of this first generation? And for second generation, mobile assisted handoff, and what is the time required? What is the power margin is required for this? And for third G, that is 3G, that is mobile controlled handoff. How much is the time handoff is required, and what is the power margin for this? This is what the full concept of this handoff. Next point is interference and system capacity. Interference and system capacity. What is interference? What is interference? The interference is nothing but two signals has to be interfere with each other. The collision between the two signals. That is what interference. If there is a more interference, the capacity of the system will be decreases. For that, he has mentioned this point, that is interference and system capacity. Why? Because if you reduce the interference, the capacity of the system will increases. Okay, if the interference is more, capacity of the system will be more. So he has divided this interference into two types. One is co-channel interference and one is adjacent channel interference. Write down these types of this interference. So just a little bit notes you have to write. Whatever I will tell you. The interference, there are two types. One is co-channel interference. Second is adjacent channel interference. Co-channel is nothing but for a sufficient distances. That is co. Adjacent is neighboring side by side. Adjacent is side by side. Co-channel is for a sufficient distance, that is interference. Where the interference is less in this, for a co-channel, the interference is less. For a co-channel, interference is less, and the system capacity is more. For a co-channel, interference is less and the system capacity is more. For adjacent channel, interference is more and the capacity of the system is also less. But if you use the frequency of one cell, is different frequency of other cell, the interference will be less in this adjacent channel. If we use the same frequency for both the channels in adjacent channel, if you use the both the frequency band is adjacent channel, the interference will be increases. There is a collision between the two signals, so capacity of the system will goes on decreases. What is the meaning of this interference? When two or more electromagnetic waveforms, when two or more electromagnetic waveforms to form a resultant wave, in which the displacement is either reinforced or the cancelled. The meaning of this, when two signals are going for one cell, one signal for one cell, other signal, but both the signals are using the same frequency band, if they are going to provide the resultant waveform, but at that time if the frequency band is same, that has to be cancelled out. Reinforce is nothing but strengthening the signal. So you have to take care for this interference is what maximum you have to use the different frequency band for this interference. The interference problem associated with the mobile communication equipment are because of problem of the time congestion within the electromagnetic spectrum. There is no time congestion between the electromagnetic spectrum, so that this interference will be occurred mainly for this system. It is limiting factor in the performance of cellular system. If the cellular system you are using, the interference will goes on decreases. Why? Because in the cellular system, what we have done, the frequency used in one cell, the same frequency cannot be used in other cell. So interference is go decreases. Okay. The interference can occur from clash with another mobile in the same cell. I already explained you the interference is how the interference is occurs if both the cells are using the same frequency band. So that is going to occur. There can be interference. One more interference can be occurred because between the base stations operating at the same frequency band. I already told you that is the frequency band is same. The base transistor station frequency band is same. That is going to occur the interference. And the interference is also occurs where the voice channels, that is a crosstalk, is heard will appear as a noise. For example, what? आप किसी को कॉल किया, आप एक फ्रेंड को कॉल किया, पर आपके कॉल दूसरों को लगा, आपको वो सुनाई दे रहा है उनका वॉइस, दैट इज क्रॉसटॉक. दैट इज व्हाट? क्रॉसटॉक. किसी और को लग गया हो, मतलब उनका वॉइस आपको सुनाई दे रहा है, पर आपका वॉइस उनको नहीं सुनाई दे रहा है, उनका वॉइस आपको सुनाई दे रहा है. दैट इज व्हाट? इंटरफेरेंस. That is what? Interference. There is a crosstalk. Crosstalk has been occurs in this. The crosstalk this is going to create because of this interference. And this interference is more in the urban areas. Why? Because there is a many population is there, and many number of people are going to use the mobile phones. They are going to use the mobile phones. So the RF noise, the radio frequency noise is there. So it is going to use this interference will be more in the urban areas as compared to the suburban areas. How this is interference occurs? This interference occurs when the frequency band of one cell is same for a frequency band of other cell, or the two BTS or the two base stations are operating on the same frequency band. This interference is going to occur. And interference is also occurs. There is a crosstalk between the two signals. Interference is going to occur. This interference is more in the urban areas as compared to the rural areas. So because we are using the more and more mobile phones and more base stations. And interference can be divided into two parts. One is co-channel interference and second is adjacent channel interference. What is an co-channel interference? In short form, it is called as CCI. CCI. For the efficient use of available spectrum, it is necessary to reduce the frequency bandwidth over the relatively small geographical area. Why we are using co-channel interference is, if we are using the frequency band of one cell, the same frequency band can be used in other cell with the sufficient distance. a maximum distance with a sufficient distance, that is called as a co-channel interference. As cells where the same set of frequency is used, as the cells where the same set of frequency is used as called as co-channel cell. Co-channel cell with a sufficient distance. Okay. Co-channel interference is the crosstalk between two different radio transmitters using the same radio frequencies, at the case of co-channel cell. If by mistake, if 10 to 20%, that is 5 to 10% of this interference is occurs only because of this crosstalk. Only because of this crosstalk. And this co-channel interferences occurs because of different weather conditions. If the weather condition is bad or frequency planning is bad, that is this co-channel interference has to be used. And this co-channel interference is going to occur if the cell size and the power transmitter at the base stations are same. The size of a cell and the transmitted power of the BTS are same. This CCI, that is co-channel interference, is become independent of the transmitted power and only dependent on the cell size, radius of the cell, that is to be calculated by R, in bracket capital R, and distance between the interfering co-channel cell, that is in distance D, capital D. That is co-channel interference is independent of the transmitted power but only dependent on the radius of a cell, that is R, capital R, independent on the radius of a cell, that is capital R, and the distance between the two cells, so that is D. You have to calculate this distance between the two cells and the radius, that is R. If D by R ratio is increased, then the effective distance with the co-channel cell will also increases. Interference will be decreases. A radius of cell is decreases and distance is increases, interference will be decreases. Radius of cell decreases, distance between the two cells increases, interference is decreases. This type of happens in co-channel interference. And you have to calculate this parameter Q, that is frequency reuse ratio. The Q is nothing but what? Frequency reuse ratio. The parameter Q is frequency reuse ratio and is related cluster size, that is Q is equals to calculated by D divided by R. D is nothing but what? Distance between the two cells, and R is nothing but radius of a particular cell. Distance between the two cells, that is a capital D, and capital R is nothing but the radius between the two cells, that is the calculated by frequency reuse ratio. Q is equals to D by R is equals to square root of 3n. What is n? What is capital N?
Size of cluster.
Good. Size of the cluster. The size of a cluster is what? 3, 4 or 7 or 9 or 12 or 21. Anything. Okay. That is to be n is what? A size of a cluster. This is what they had given some of the one diagram, that is D minus of R. D is D minus R and D plus R. D minus of R is nothing but if the mobile is distance is closest to the cell, minus subtraction. The mobile is at a distance at the closest of the cell, that is what? D minus of R. D plus R, distance from the two interfering cell, that is far away from the particular base station, that is called as co-channel interference. That is called as what? Co-channel interference. Okay. These are the two types of interference, and adjacent channel interference is nothing but the neighboring cells. The neighboring cells, that is called as an adjacent channel interference. This adjacent channel interference is going to create a more and more interference. Why? Because sometimes the two signals are going to interfere with each other. That has to be taken care by the frequency band. What the same frequency you're using, there is a lot of interference has to be taken place in this. Okay. The interference for adjacent channel we'll see tomorrow for this. Okay. And co-channel cell, and we have seen today, we have seen the end-off and co-channel interference. Adjacent channel, just you have to remember this. Adjacent channel is nothing but the interfering cells. Okay, there is a leakage in the frequency band. If there is a leakage in the frequency band, it is going to create a more and more disturbance in the adjacent channel interference. That has to be calculated by signal to interference ratio. That has to be calculated by signal to interference ratio, that is S by I. S by I is equals to 10 raised to minus of n. N is a number of channels we can use. Okay, we'll stop today and we'll continue tomorrow for this. Be prepared for this. Whatever I taught, you have to remember this. Your attendance